Give me 5 minutes. Right. Last class, where we were now? 2.4. Various formats of sampling distributions I completed. So then last class, formats of sampling distributions is completed. I think I completed that. Okay, where the formats of sampling distribution 2.4, the various formats. Formats of sampling distribution. Section 2.4 is over. What about again? Last class. Formats of sampling distributions. කොතනද නැවතුනේ class එක?
Madam, we stopped at sampling distribution of sample proportion.
Sample means. Sampling distribution of sample means difference between sample two means, that is section 2.4. That section 2.4 is over, I think. Section 2.4. Various formats of sampling distributions, difference between two means and all, 2.4. So, do you have a note 2.5 today? 2.5 එක තියනවාද confidence intervals? 2.5? No 2.5? 2.5 note එක තියනවාද?
Yes, miss. Yes.
Yes, right. Today we have to start that 2.5. 2.5. Right. So, various formats of sampling distributions. So then we know about the sampling. What is a sampling distribution? And it has some special properties. ඒකේ තියෙන විශේෂ ගති ලක්ෂණ. So then the mean of the all sampling distributions is equal to the respective, the corresponding population parameter, and there is a relationship in between the variances. So then under two different conditions, so then from finite populations, from infinite populations, once we sampling with replacement and then sampling fraction less than 0.05. So then it is the population variance over sample size. So otherwise, you have to multiply them by correction factor. And not only that. So then we verify them. So there are some the different kinds of populations with you. So then you are going to sampling with normal populations, non-normal populations. So then large and small samples, variance is known and unknown. So then there are small differences. So we know that sampling distribution is normal distribution in lot of situations, but then only two cases. So then it follows another distribution which is known as T distribution. So then in detail, everything I completed 2.4. So now by using these special properties of the sampling distribution, so now we can do the estimations. So what is that? Now we are going to estimate the population parameters based on sample data. Based on sample data, that is your section 2.5. The confidence interval is one kind of the estimation. Now we are going to studying and one important part. So now this is the confidence interval 2.5. So now we are going to do these estimations. So then by using the special properties of our sampling distributions. Right. මේ sampling distribution එකේ තියෙන මේ properties පාවිච්චි කරලා තමයි අපි දැන් මේ estimations කරන්න යන්නේ. Confidence intervals. Statistical estimation. Statistical estimation. What is that? The process of expressing the unknown population parameter using sample statistic derived based on random samples drawn from a population is known as statistical estimation. Now, really, what is that? So, based on some sample data, so we are going to making the estimations about the unknown population parameters. So now this statistical estimation is in two types. So there are two different kinds of estimations are there. One is point estimation and the other one is interval estimation. සිංහලෙන් කියනවා ලක්ෂ්‍යමය නිමානකය සහ ප්‍රාන්තර නිමානකය. Point estimation and interval estimation. ලක්ෂ්‍යමය නිමානකය ප්‍රාන්තර නිමානකය. So what is your point estimation? Estimating the unknown population parameter to a single value, considering the sample statistic as estimation is known as the point estimation. Point estimation. What's a point estimation? So now let's say we need to estimate about the unknown the population mean mu. So then unknown population mean mu. So what we are going to do? What is the corresponding estimator is sample mean. So once we have drawn the correct, so then by using, there are a lot of sampling techniques we learned at the beginning of the lesson. So then once we draw the sample from that population by using the correct and most suitable sampling method, so then what we are going to do, we calculate the mean of that. Now let's say your sample mean is, now you are going to estimating the population mean. Now you have drawn a sample by using our most accurate sampling technique and calculate the sample mean. So now let's say we have an answer. Now let's say marks of students. So that is 55. So we consider if our sample mean is 55, the population mean may be 55. So that's why a single value considering the sample statistic as the estimation is known as point estimation. So if අපි සිංහලෙන් කිව්වොත් එම් කියන්නේ මොකද්ද? අපිට ඕනේ නම් population mean mu. ඒ කියන්නේ අපි ගත්තොත් සංගහන මධ්‍යයන්නේ අපිට estimate කරන්න. අපි ඒ සංගහණයෙන් ගන්නවා. So then what the sample. So then by using the correct sampling technique. වඩාත්ම ඒකට ගැලපෙන හොඳම sampling technique එක අරගෙන so we calculate the sample mean. ඒකේ mean එක ගන්නවා. මධ්‍යයන්නේ අරගෙන so we say that that may be our population mean. ඒක අපේ population mean එකත් ඒකම වෙන්න පුළුවන් කියලා කියන්න පුළුවන්. Estimating a unknown population parameter by considering a single value. ඒ කියන්නේ sample mean එකෙන් අපි population mean එක estimate කරා. So the function of sample elements which are used to estimate the value of unknown parameter is known as estimator. අපි ඒකට කියන්නේ ගැලපෙන එක estimator. So then for population mean, estimator is sample mean. Population proportion, estimator is sample proportion. With so few estimates used to estimate unknown parameter, few estimations. For another examples here, sample mean x bar for estimating population mean mu. So you have to take the corresponding one. So then sample proportion for estimating population. Difference between two sample means for estimating difference between two population means. Difference between two sample proportions for estimating difference between two population proportions. So you have to take the corresponding suitable estimate. The value derived by computing the estimator based on the single sample data is called estimate. That numeric value, let's say as I told you now 55. 55 is your estimate. So sample mean is an estimator. So then that value is 55. So now we call 55 is an estimate. Single right. Then as a note, now look at this point estimation method has some limitations. මේකේ තියෙනවා අඩුපාඩු ගොඩක්. අපි point estimation එකකින් කරන්නේ අර sample එක අරගෙන ඒකේ ඒ measurement එක calculate කරලා ඒකම තමයි අපේ population parameter එක කියලා estimate කරන්නේ. That is called point estimation. So then there are a lot of limitations. ඒ වගේ මේකේ ගොඩක් අඩුපාඩු තියෙනවා. What are those limitations? So when conclusions are made for the population, problems are arisen regarding the accuracy and precision is estimating with a single value for large quantity of items. එතකොට there is so then problems arise. ඒ කියන්නේ අපිට ගැටලු මතුවෙන්න පුළුවන්. අපි මෙන්න මේ වගේ එක single value එකක් අරගෙන අපි population parameter එක estimate කරපුවාම. So why? Since knowing idea about the variance of the estimate. So nothing can be expressed about the variance or variations or distribution of a population. එතකොට මේ point estimation method එකේදී so we are not considering about the variance of our sampling distribution. There is a very good relationship in between the variance of our sampling distribution and population parameters. You know, so then in case of the sampling distribution of sample means its variance is equal to the population variance divided by sample size. So now in case of point estimation, so we are not considering about that the variation of the variance of our sampling distribution, and not only that. So what else? So then they are not considering about the nature of a population. Then the nature of a population so we are making 5 different cases with sampling distribution of sample mean as well as difference between two sample means. අපි ඒ දෙකේම අපි එක එක cases analyze කරලා so there are some small differences among them. So then we identify. So then know any idea about those things once you are using your point estimation. Point estimation has some limitations. So then there may be the problems arising become the accuracy of our estimate. අඩුපාඩු තියෙනවා. අපි මේ population parameter එක අපි estimate කරපු විදිහේ ඒ කියන්නේ නිර්වද්‍යතාවය අපිට හරියටම තහවුරු වෙන්නේ නැහැ. So therefore we must find out some alternative. අනේ නිසා අපි තව alternative එකක්. එහෙම නැත්නම් විකල්පයක් හොයාගන්න යනවා. So then for the get the better estimation. අපිට ඔයිට වැඩිය හොඳ estimate-ක් ගන්න. So then we are going to find out some alternative. Right. So what is that alternative? That alternative is your interval estimation. අපි කියනවා ප්‍රාන්තර නිමානකය. Now here what we are going to do? Now we are going to constructing the interval of the what do you call range of values. So then the population mean, let's say any population parameter lies between two limits. So we are constructing an interval. අපි තනි අගයක් නැතුව. So we are going to make an interval. If our sample mean is this much, sample mean එක මේ ගාන නම් population mean may be in between these two particular figures. මෙන්න මේ අගයන් දෙක අතර තියෙනවා කියලා by considering some other factors. අපි අර අතෙන්දී reject කරපු factors. So what are those factors? So what is the variance of our sampling distribution and what is the nature of a population? You drawn your sample. By considering all those factors, so now we are making interval estimation by what you call overcome all limitations comes under point estimator. Point estimation method එකේ තියෙන අඩුපාඩු ඔක්කොම මේවා කරලා now we are going to introducing about the interval estimation. Estimation. So in an interval estimation, so then interval estimation means that deriving a range of values considering the point estimator matching with its standard error. Standard error is what? Standard deviation of a sampling distribution. And confidence level with the purpose of estimating the range within a population parameter is expected to be contained. So here we are introducing the range of values by considering other factors. In simple. So in point estimation, only the value of the estimator is used to estimate the population parameter. අපි ඇත්තටම estimate කියන එක විතරයි අපි ගන්නෙ. So that is what is the number value we are using for our estimator is we are using only for in case of point estimation. හැබැයි මෙතෙන්දී අපි in interval estimation a range of values in which the parameter may be contained is derived and in addition to the value of estimator considered about following factors. The population distribution. අපි එතෙන්දී මේ population එකේ distribution එක ගැන ඔයලා බලමු. And standard error. What is the standard error? The standard deviation of a sampling distribution. Confidence level. Confidence level. අපි ඔකට සිංහලෙන් කියනවා විශ්වාස මට්ටම. What is that confidence level? I think other two are okay. අනිත් දෙක ගැන ඔයගොල්ලෝ දන්නවා. So what about the confidence level? So now in all our real world, real world, the perfectness is not the exist. Again, perfect does not exist. So as an example, now let's say now here we are going to making an estimations based on a sample about the population parameter. Sample එකකින් තමයි අපි population parameter එක estimate කරන්න යන්නේ. So then there is a difference between the sample measurement and population measurement. So that is called sampling error. Api kochchara hari. So then if you are using the most suitable sampling technique, that sample and a population are different, two different things. So then sampling error is occurred. Ehinda sampling error එක අනිවාර්යයෙන්ම පවතිනවා. එහින්දා so then all these estimations, so we are making with a particular confidence level. ඒ කියන්නේ අපි සිංහලෙන් ඔකට කියන්නේ විශ්වාස මට්ටම. මෙන්න මේ අගයන් දෙක අතර පවතින්න පුළුවන් මෙන්න මේ ප්‍රමාණි විශ්වාසයක්. 95%, 99%. So we are introducing one percentage. So that percentage is really more than 90, 95. So then if you are making the 60% confidence interval, that is not valid. සාමාන්‍ය 60ක විශ්වාසයක් තියෙනවා කියන expression එකක, so then it's not valid. So therefore we are introducing our confidence interval. So then that is with the number greater than 90 or 95. 95 වගේ ඉලක්කමක් එක්ක confidence level. Confidence level. Why is that? Because of our sampling error. Because of our sampling error. At sample එක කියන්නේ population එක නෙමෙයි. So then once you are using the most accurate sampling technique. So therefore, so we are introducing the confidence level also. Now then in interval estimation, everything is completed. So we are considering about the nature of a population. So then not only that, so what is that? What is the variance of a sampling distribution, and what about that? The other one is the confidence level also. Confidence level. So then we can't make the perfect interval estimation. Perfect. Samani. So then perfect, the concept perfect is not exist. Paripurna කිසිම දෙයක් පවතින්නේ නැහැ. It is not exist. So then normally, you know, the most valuable metal in our world is the gold. අපි දන්නවා රත්තරන් ගොඩක් වටින ලෝහයක්. So if you are making jewelries by using pure gold, gold වලින් විතරක් අපි රත්තරන් බඩු හැදුවොත් මොකද වෙන්නේ? So then can't be used. ඒ මේ පාවිච්චි කරන්න බෑ. කැඩිලා යනවා. So then what we are going to do? So we mix some copper. අපි සබ ටිකක් දාලා තමයි ඒක හදන්නේ. So then the light cap 22 carats, 24 the carats කියලා දාලා තියෙන්නේ. So then the percentage of the copper mixing. So to it is for existence. So exist ඒක පවතින්න. So we have to mix them. That is our reality. ඒ තමයි අපේ ඇත්ත. That's our reality. So then, and one more example. So then you are studying very hard for your exams. So then one student who's studying very hard. So let's say 24 hours. So he studied 20 hours. So then in our, according to our theory of perfect, the students studying hard, so all can go through the examination. So are all 100% students go through the examination? So ones who studied hard, පාඩම් කරලා කරපු ළමයි ඕන තරම් විභාග තේල් වෙන්නේ නැද්ද? So there is a small percentage is there. So then they can't fail. Again, so then unfortunately. So therefore the perfect. Again, අපි කියන්න ඕනේ පැය 24ම පාඩම් කරන ළමයි විභාගේ පාස් වෙන්න ඕනේ. 100%ක්ම පාස් වෙනවද නැහැ. So then there is a small percentage, unfortunately, they can't achieve their goals. ඒතකොට ඒගොල්ලන්ට ඉලක්කයට විභාග ඉලක්කයට යන්න බැරුව යනවා. පොඩි කොටසක් ඉන්නවා. So like that, all these estimations, so then we are introducing with some confidence level. That's our reality. And the confidence level ki like introduce karna. So now here, now we learn, now it is okay with the nature of a population and the standard error is okay. So how we convert that confidence level as a number? It was a confidence level, like now we are going to convert into a number. So then now we add that number in our confidence interval part. So now we'll see how to do that. Confidence level එක දුන්නාම ඒකට අදාළ ඉලක්කම අපි කොහොමද ගන්න කියලා තමයි. So now we are going to study how we do that. So now look at this example. When the variance of a normally distributed population is known, this is case 1. The population mean mu is estimated using a sample as in point estimation, mu is the estimated using the sample means derived from the sample. In interval estimation, sample mean, standard error, sigma over root 10 and table value Z under given confidence level. So then how we convert this confidence level as a number? So then now you know that the sampling distributions. Now we learn about various sampling distributions. Lot of sampling distributions follows a normal distribution and so very few of them follows a T distribution. ගොඩාක් ඒවා normal distribution එකක් අපි අවස්ථා දෙකක් විතරක් තියෙනවා, they are the T distributions. So then we convert our confidence level by using that Z table and T table. I think you are familiar with the Z tables. Normal distribution එක දන්නවා in lesson 1. So we use that and the T distribution is also there. So now then, in case of T distribution, so we are using T table as a number for our confidence level and so Z table as a number for normal table. Normal distribution එකක් නම් අපි Z table again, so we make some number to confidence level and then if it is T distribution, so we are using T table value, T distribution table, right? Do you have the tables today? Normal distribution table එක තියනවද ළඟ? Normal distribution table එක තියනවද? Normal එකයි T distribution කියලා තව එකක් තියෙනවා. ඔයගොල්ලෝ ගාව තියනවද ඒක? Do you have it? තියෙනම් අරන් එන්න පොඩ්ඩක්. ඔයගොල්ලන්ගේ අර පොත්වල ඇති මං හිතන්නේ. අර ටෙක්ස්ට් බුක්ස් වල ඇති පිටිපස්සේ. normal distribution එකයි t distribution එකයි අරගෙන එන්න. විනාඩි 5ක් විතර මන් දෙන්න. bring your normal distribution and t distribution. අරගෙන එන්නේ distributions දෙක. I'll give 5 minutes. Bring your two normal distribution table and t distribution table. Tables දෙක අරගෙන ඉන්න විනාඩි 5ක් විතර මන් දෙන්න. Yes. Have you bring it? ගෙනාවද table එක?
Going forward, Indian agri companies campaign in the US, we need this 10 years content.
අරන් එන්න tables දෙක හැමෝම.
Needs to happen as there is a regulated body that is sending out messages. Share group weekend.
That is Mario is asking for a number to say. We will have justice, right? Justice number. I will let you know.
ගෙනාවද tables දෙක? Have you bring it? Tables දෙක ගෙනාවද? ළමයි හොයාගත්තද? normal distribution එකයි t distribution එකයි?
Oh,
Do you
miss.
have it now?
Yes.
Oh, yes, right. So before that, have you got your marks are released for assignment? Have you got good marks? ලකුණු හොඳට තිබුණාද assignment එකට? ළමයි?
Yes, miss. Yes.
Yes, madam.
Yes.
Yes, madam.
Madam.
So put your marks to the group. Group එකට දාන්නකෝ අපිටත් බලන්න. Put your marks to the group. And I forgot to tell you the one more message to you. So then are there a lot of students who missed the lesson 1? Lesson 1 එක miss වෙච්ච ළමයි එහෙම ගොඩක් ඉන්නවද? තව ඕන අය එහෙම? Are there any students? Lesson 1? ඉන්නවද? Are there any students? So then the recordings are releasing for the lesson number 1. So then some students put the marks, no? Right. Marks ටික දාන්න group එකට බලන්න මට. And the students who missed the lesson 1, පළවෙනි පාඩම miss වෙච්ච අය ඉන්නවනම් recordings ටික දෙනවා මං හිතන්නේ. recordings ටික ගන්න. එහෙමත් තව මොනවා හරි ඕන නම් as a like a revision in the normal physical class, the online class. So then if let me know. එකතු වෙලා එහෙම තව එක කාට හරි ඕන නම් so then are there the lack of students who need the lesson 1 also, the students who missed that. So then I can make by taking like 4 hours 6 hours on one holiday නිවාඩු දවසක මම උනම් ඒක කරන්නම්. or so you can go through the recordings වලින් හරි කාට හරි class එකකුත් ඕන නම් then if let me know. Right. Now we'll see how to convert the, put your marks to the group. So then I can't read because ඔයගොල්ලෝ ෆෝන් එකට දැම්මට chat එක මට සමහරවිට පේන්නේ නැහැ. මොකද මම මේ ස්ටෑන්ඩ් එකට ෆෝන් එක ගාලා තියෙනවා. Right. Now we'll see how to convert our confidence level as a number. Right. Now first one for the normal distribution. ඉස්සෙල්ලා බලමු lot of sampling distributions follows a normal distribution. සමහරවිට ඕගොල්ලෝ හිතනවා कि මේ විස්තර ගොඩාක් මම කියන එක වැඩි කියලා ඕගොල්ලන්ට එහෙම හිතන්න එපා because why? So then once you are going to use and any question is not given to the format. අර ඕගොල්ලන්ගේ paper එකේ format එක පොඩ්ඩක් වෙනස් කරලා આવොත් if you do not have any idea මටත් ඔන්න මේක කියන්න පුළුවන් confidence interval has a formula. මෙන්න මෙහෙම එකක් තියෙනවා. මේකට මේක දාලා උත්තරේ ලියන්න කියලා. So then that is not the method of teaching. ඒ කියන්නේ ගණන් කටපාඩම් කරවන්න මම කැමති නෑ ඕගොල්ලන්ට. So then you must have a particular knowledge. So then if your question paper format is changing or whatever, so now your object is to answer the, so well answer to your question paper. ඒක වෙන්න ඕනේ. හැබැයි so then you must have knowledge also. දැන් පොඩක් පොඩි හරි දැනුමක් ඇතුව ඕනේ ගන්න. ඒ හින්දා පොඩක් මේ කරන විස්තර තියෙන ඒවට. So then you just trying to listen to me and trying to understand. Right, now we'll see how to convert this confidence level as a number. First of all, we'll see if the sampling distributions follows a normal distribution. බලන්න මගේ first example. Example number one. Example number one. So, if sampling distribution of sample statistic, maybe sample mean or proportion or whatever, sample statistic follows a normal distribution, derive the table values related to each confidence level given below. එතකොට හැම ගණන් වලම අපිට දෙන්නේ 95, 99. So any number is given. So you just learn the method. එතකොට so that number is even 80%. 80% කියලා දුන්නා. So how we convert the so that confidence level as a number. Now first example is follows a normal distribution. 90% confidence level, 95% confidence level, and 99% confidence level. What are the relevant numbers? So in normal distribution, now this is your method. Right, so 90% confidence interval. Now this is for example one. Example one, 90%. Now this is a normal distribution. So first one, 90% confidence interval. Confidence interval. So now if any percentage is given, so in case of normal distribution, divide that percentage by 2. May percentage එක දෙකෙන් බෙදන්න. 90% divide by 2. What is that? 45%. So then convert them as a decimal. 0.4500. Now, your normal distribution. Mean is 0. So what is your confidence level? Confidence level is, so now we make that statement with a particular confidence level. So then 100% accurate. So estimations cannot be done. It is not a reality. So that's why this, now here there is one percentage. Now here 90% confidence interval means 10% may be out. 90% confidence interval කියන්නේ 90ක් තමයි මේ statement එක හරියට පුළුවන් ඇති. එතකොට 110ක් out වෙනවා. ඒ 110 අපි mark කරනවා දෙපැත්තෙන් balance වෙන්න 5% here and 5% here. So therefore this blank area is 45%. You know 1/2 of a normal distribution with 50%. එතකොට 10% out means so 5% on right edge and 5% on left edge. එහෙමනම් so now here there is 90%, so as 1/2 with 45%. 0.4500. Right. Now you refer your normal distribution table and let me know what is the Z value as the area closer to 0.4500. Here there is no exact value. මේක හරියටම එකක් නෑ. area එක 0.45 වෙන Z value එක මොකක්ද කියලා බලන්න. As 0.4500 Z value. 0.4500. What is your Z value? Balan table again. So follow up your normal distribution table and let me know what is that number. 0.4500 වලට ආසන්නම අගයම කවුද කියලා බලන්න.
1.65.
Yes, 1.65 or 64 both can be taken. If you take one of these numbers, that is correct. Others, find out that is plus or minus 1.64 or 1.65. මේ දෙකම හරි 1.65. එක්ක මේක 1.64 එහෙම නැත්නම් 1.65. For both numbers, they will give marks. 1.65. Now this is the number with 90% confidence interval. So then you catch the method. What you are going to do, if our sampling distribution follows a normal distribution, the given percentage divide by 2. Make a decim redundant. So then make that percentage as a number. So you follow up your normal distribution and find out what is the closer value to that. Now this is plus or minus 1.64 or 1.65. Right, the same technique. Any percentage is given. ඕන එකක් දුන්නාම මේක තමයි if our sampling distribution is a normal distribution. So now anyhow there are two more questions are there. What about our 95%? 95% confidence interval. Second one 95% confidence interval. So then 95% divide by 2. 95% divide by 2, that is 47.5%. As a decimal, 0.4750. 0.4750. What would be the Z value for that? There is exact value. Make a item 4750. What is the number as 0.4750? So now here 5% out, each edge has 2.5%. So deduct 2.5. So blank area is 47.5. 0.4750. What is your value? Area is 0.4750. There is one exact value.
1.96.
1.96. What is the Z value is plus or minus 1.96. 96. So you have to use here plus 1.96 minus 1.96. Any percentage is given, technique is same. හැම වෙලේම මේකම තමයි technique එක. So then finally 99% confidence interval. 99% confidence interval. Third answer. 99% confidence interval. Confidence interval. So 99% divided by 2. 99% divided by 2, that is 49.5%. As a decimal, 0.4950. Right. So then 1% out. The 1% out now, 0.5% on both edges. 0.5%. So what is that? 0.4950. What is this? Make here 0.4950. 4950. What is your Z value? Plus or minus? I think here also there are two values. දෙකක් තියෙනවා මම හිතන්නේ. 4950.
Yeah. I
Okay, guys, so let me understand this now. You're using a temporary solution.
2.57 minutes.
2.57 and 2.58 both. What I can do? 2.57, 2.58. 2.58. This is what I can. 2.57 or 2.58.
So what about
2.58. So then the questions. So then any percentage is given with the normal distribution. divide the percentage by 2. It was a convert them as a decimal and then look at your table and get that answer. ඊළඟට ඒකට සමාන එක කොහෙද තියෙන්නේ කියලා table එකේ බලලා උත්තරේ ගන්න. So it is for the normal distribution. If it follows the normal distribution. Right. Your example 2 is t distribution. So very few, only 2 cases. The sample mean එකේ difference between two means කියන එකේ there are only 2 cases. So it follows a t distribution. Now we'll see how to use t value. You never use your t distribution before. මේකට ඉස්සෙල්ලා ඔයගොල්ලෝ කවදාවත් t distribution එක පාවිච්චි කරලා නැහැ. Now we'll see how to use our t distribution. Example 2. Example 2 එකෙන් බලමු අපේ t distribution එක පාවිච්චි කරන්නේ කොහොමද කියලා. So then take out your t distribution. Example number 2.
That said, that's what I'm doing.
If sampling distribution of sample statistic follows a t distribution, derive the value of t in accordance with the each confidence level and sample size. So what will happen? So now if it follows a t distribution, so then not only the confidence level, sample size also given. Why is that? Can you remember the properties of t distribution? Previous chapter. So I explained properties of t distribution, and the last property is what? There are some set of t distributions depending on the value, degree of freedom or the sample size. එතකොට අපි t distribution එක ඉගෙන ගත්තා. t distribution එකේ තියෙනවා there are some set of t distributions depending on a sample size -1, degree of freedom 5, the more flatter, degree of freedom 12. ඒ කියන්නේ sample size එකෙන් එකක් අඩු කරපුවාම මේ ඉලක්කම තමයි degree of freedom කියන්නේ. එතකොට ඒක අඩු ගාණක් නම් so then your t distribution is for the wide and flatter. ඒ කියන්නේ අර නිකන් පැතලි. එතකොට ඊට වඩා ටිකක් පැතලි බව අඩුයි if your degree of freedom is like 12. 12 13 වෙනකොට ඒක තව ටිකක් අර narrow වෙලා යනවා, කෙට්ටු වෙලා යනවා. So then if it is like closest to 30, 30ට කෙට්ටු වෙනකොට we are using as small samples. T distribution for small samples. Small samples are sample size less than 30. Sample size එක 30ට අඩු ඒවට තමයි අපි small samples කියන්නේ. 30ට කිට්ටු වෙනකොට it is like 25. So degree of freedom is 24. So then it closes to a normal distribution. එතකොට ඒක තව ටිකක් අර පැතලි බව අඩු වෙවි යනවා. There are some set of t values. So set of t distributions. So that's why, so once you are going to construct a confidence level based on a t distribution, you need confidence level and sample size both. Hari, අපි පළවෙනි එකෙන් බලමු what is the method. Now first one, example number 2.
Let's say 28. Here's what I want to do. Here's what I want to do. I don't know if this. The first blocker, the line blocker, what are all these blockers?
So the first is to make the detail of this breakdown. They said that that's the block.
Example 2.
Then they also want a filter, but that was the document that's also valid.
What is the first one is 90% confidence interval n is equal to 90% confidence interval
Exchange to get the mean and the subject.
and sample size is 10. Sample size is 10. Now in case of t distribution, so we are not going to dividing by 2 our given percentage. අපි normal එකේ නම් 90% කිව්ව ගමන් 90 divide by 2. Now here we divide the rejected percentage by 2. So then 100% minus 90%, 100% minus 90% is 10%. 10% divided by 2, that is 5%. Convert them as a number 0.05. Now here we divide the rejected probability by 2. So and convert them as a number 0.05. And so now you calculate degree of freedom. Degree of freedom is n minus 1. 10 minus 1, that is 9. So now here you needed the rejected percentage divide by 2 and convert them as a number and degree of freedom. Degree of freedom is sample size minus 1. So now sample size minus 1, that is 9. Degree of freedom 9, and so the percentage is 0.05. Now refer your T table. T table එකේ තියෙන මෙන්න මේ වගේ. So you have degrees of freedom. මෙතන තියෙනවා from number 1 up to Even a 29 or 30. So 1 up to 30, 29. And there are some columns. When we are looking. Your T table, DF. 1, 2, 3, 4. Up to 30 or 29. And then there are some columns. 0.1, 0.05, 0.025. Anything on it? 25, 0.01, 0.005. Ito balang under 0.0059. What is this value? Can make it balang 0.005. Sorry, 0.05. Degree of freedom is 9. You have grown a sample with size 10. Make it balang 0.05. Degree of freedom 9. What is your table value? What are the table value? I draw a diagram of T distribution. And the T distribution again. Degree of freedom 9, 0.05. Make it 0.05. Degree of freedom is 9. This is a T distribution with degree of freedom 9. What are the T table value? 0.05.
1.8331.
Sorry, I can't hear. Hear that?
1.8331.
1.8331, that's correct. 1.8331. 1.8331, that's correct. 1.8331. 8331 minus 1.8331. So that is the method for T distribution. Now find out your degree of freedom and rejected probability divide by 2 and then make them as a decimal. Follow up your T table. So then T table has set of T values. Again, so there are set of T distributions are there depending on the sample size. So that's why they have to given the sample size. Sample size degree of freedom. Right, next one. 95% N is equal to 85. Ninety-five percent. 95%.
Then we, they are currently testing.
95%.
Yeah, yeah.
So to install, to test API.
Sample size 25. 25. So 100% minus 95%, that is 5%. 5% divided by 2. 2.5% as a decimal, 0.025. 0.025. What is your degree of freedom? N minus 1. 25 minus 1, that is 24. Right. Now go through the degree of freedom 24, 0.025. 0.025. What is your T table value? Yes, what I'm making. Degree of freedom is 24. 0.025. Degree of freedom 24. What are the T table values?
So that's it.
2.0639.
Sorry?
2.0639.
The 2.0639, that's correct. 2.0639. 0639. थोड़ा अपनी टेबल लेके बनाने. So 0.025. Degree of freedom 20. 2.0639. मैं तमाम method लेगा. This is the method how to follow your T table. So last class, 99% confidence interval. 99% confidence interval.
So why don't I say
99% confidence interval.
over this?
What is the sample size? Sample size is 30. Sample size is 30. N is equal 30. Again, 100% minus 99% is equal 1%. 1% divided by 2.5%. As a decimal, 0.005, 0.5 over 100. So that is 0.5% can 0.5 CM with. So how to convert the decimal as percentage as a decimal? 0.005. 0.005. Degree of freedom. Degree of freedom is equal n minus 1, 30 minus 1, 29. Now what is your degree of freedom? 29 and 0.005. Find out your T table value.
I just said this and bring along this, okay?
So degree of freedom 29,
Let's get over the ground and bring it all back.
0.005. What is the table value?
We have to conclude to 196.
2.7633.
2.7633, that's correct. 2.7633. 2.7633. Now these are the T values. 2.7633. Right now, this is the method how to follow up your T distribution. So there are two kinds of sampling distributions with us. So the normal distribution and T distribution. So then the confidence interval is given. So how you make the confidence interval is given, level is given, how you make them as a number. Now you have to consider them. So whether if it is follows a normal or T distribution, you know about those situations, right? Right now, by gathering all information together, so what are the properties of the sampling distribution? So then their mean is equivalent to the relevant population parameter, and there is a relationship in between variance of them, where the population variance and the variance of a sampling distribution and all. So now we can make the common formula for the unknown population and by using our confidence level. Make confidence level like so we can make a common general formula for the confidence intervals. Confidence intervals general formula. My note, I will give the derivation of this method. Make up derive කරන විදිහත් මම මේ note එකේ දාලා තියෙනවා. මම හැබැයි at the moment I am not going to explain that. මේ අන්තිම මොහොතේ last moment, so they are not asking you to derive them. ඒක ඕගලන්ට derive කියන්නේ ඔප්පු කරන්න කියලා එන්නේ නැහැ. So you can use a formula. So now I am going to give you the formula. හැබැයි මේක නිකන් කියවලා බලන්න. Now this is the by using the property of a normal distribution and special properties of sampling distribution. මෙන්න මේ දෙක connect කරලා තමයි අපි so we construct that formula. The method of constructing is not necessary. So I am going to give you the common formula now. General formula. ඊට පස්සේ අපි ඒක එක එක ඒවට වෙනස් කරලා ගමු. Confidence interval about the population mean, the population proportion, difference between two means and like that. So now first we'll see what is our common formula. ඉස්සෙල්ලාම අපි common formula එක එහෙම නැත්නම් what's our general formula. So by gathering all information together, so we are considering factors, point estimator, so and what else? So standard error of a sampling distribution, nature of a population and confidence level. මේ ඔක්කොම ටික එකතු කරලා තමයි. So we are making an equation for unknown population parameter. Unknown population parameter is equal. So there is one formula. මේ ඔක්කොම එකතු කරලා තමයි මේ formula එක හදලා තියෙන්නේ. Now we'll see what is that formula. So you can directly use this formula under various formats of sampling distributions. Right. මේකේ මේ derivation part එක පොඩ්ඩක් අයින් කරලා ඔන්න confidence interval කියලා දාලා තියෙනවා. The interval which is estimated in interval estimation is called confidence interval, which the range of values the population parameter is expected to fall under the given confidence level. Confidence level එකක් යටතේ කොයි range එකේද තියෙන්නේ කියන එක. So now look at the next page, general expression for population parameter. General expression. මේ තමයි අපේ common. So then you have to memorize it. Make general expression එක අපිට තියාගන්න ඕනේ. What is that? Population parameter. This is the one we are going to calculate. Population parameter is equal. Population parameter is equal. Point estimate. So estimator, point estimator. Like sample mean or whatever. Point estimator. Point estimator plus or minus table value. What is that table value? That is your confidence level. So it may be a Z or T value. Table value. This is your confidence level into standard error. Standard deviation of a. Now this is the general formula for evaluating our unknown population parameter. Population mean is equal sample mean plus or minus table value into standard error. So we are considering all factors now. So what is the standard error? Nature of a population and confidence level. මේ ඔක්කොම අරගෙන තමයි plus point estimator. Point estimator is not 100% equivalent to the population parameter. හැම වෙලේම point estimator. Sample mean is not 100% equivalent to the population mean. Why? Because of our sampling errors. Now this is your error term. මෙන්න මේ දෙක තමයි error term එක plus or minus. So now we call in general the confidence coefficient. Confidence coefficient is 95%, 99% කියලා අපි දෙන එකට අපි කියනවා confidence coefficient. සිංහලෙන් කියනවා විශ්‍රාම සංගුණ කියලා. ඒ වගේම confidence error. Confidence error කියන්නේ මෙන්න මේ දෙක. Table value into standard error. Confidence error. මෙන්න මේක තමයි error term එක. Point estimator plus or minus this range. මෙන්න මේ range එකේ point estimator එක ධන හෝ ඍණ කියලා අපි range එකක් ගන්නවා. So that range is our confidence error. Table value into standard error is our confidence error. Right. Now we'll see what is the most important one. Confidence interval about population mean. What is the confidence interval about population mean? Now this is the most popular questions. So with your question papers. So confidence interval about population mean mu. What is your common formula? Population mean is equal population mean. What is your corresponding estimator? Sample mean. Sample mean plus or minus. What is your error term? Table value into standard error. Table value into standard error. Right. Now we learn about there are 6 different formats of sampling distribution of sample means. So populations are normal or non-normal. So then variance is known or unknown. So then the large or small samples. According to that, there are 5 cases, 5 different formulas, 5 formulas based on each situation. එතකොට මෙන්න මේක හැටියට අපි sampling අපේ confidence interval එකට formulas කීපයක් තියෙනවා. Case 1, case 2, case 3. ඒ ටික මතකයිනේ sampling distributions. Right. පුතේ පොඩ්ඩක් සත්‍ය අඩු කරන්නකෝ. Okay. Right now here, the all 5 cases are there. Cases පහ තියෙනවා මම conditions ටික ලියන්න නැතුව. So then I'll write what are the formulas we are using about the confidence interval about population mean mu. What is your case 1? මේ ටික අපි කලින් කරලා තියෙනවා. Population is normally distributed. Population variance is known for any size of sample. Case number 1. Case number 1. Case number 1. Population is normally distributed. So population variance is known for any size of sample. What is that? Sampling distribution of sample means are normally distributed with population mean mu and what is your variance? Sigma square over n. According to that, what is your confidence interval formula? Mu is equal x bar plus or minus z sigma over root n. Table value into standard error. Make a standard error again sigma over root n. Now this one follows a normal distribution. Now you have a z value. Now this is the formula under case 1. So if you are sampling from a normal population with known variance, so for any size of sample, your sampling distribution of sample means follows a normal distribution with population mean mu and variance population variance over sample size. So therefore, what is the confidence interval formula for that? Mu is equal x bar plus or minus z sigma over root n. Now this is your case number 1. Case number 1. Normal population, known variance and for any size of sample. What is your case number 2? Case number 2. Case number 2. Population is normally distributed. Population variance is unknown for large samples. So then, from a normal population with unknown variance, once you draw a large sample, what is your sampling distribution? Sampling distribution of sample means are normally distributed with mean mu and what is your variance? S square over n. Your population variance is not known. We replace them by using a sample variance. Population variance එක දන්නේ නැති ඉඳලා අපි sample variance එකෙන් අපි ඒක replace කළා. So what is the formula for mu now? දැන් අපිට මොකක්ද දෙන්නේ? Mu is equal x bar plus or minus z s over root n. You have to write the correct formula. Sample standard deviation එක දීලා තියෙනකොට s over root n ලියන්න. අනිත් වෙලාවට sigma over root n ලියන්න. Now this is formula under case 2. Formula under case 2. What about your case 3? Case 3 is population is normally distributed. Population variance is unknown for small samples. So what will happen? Now here this is for large samples with unknown variance. Once we drawn a small sample from normal population with unknown variance. So what will happen? Case 3, case 3. Case 3. Sampling distribution of sample means does not follow a normal distribution, follows a T distribution with population mean mu. What is your variance? S square over n. Now this is a T distribution. What is the relevant formula? Mu is equal x bar plus or minus T into S over root n. Now this one with T value. Now we are dealing with T value. Now this is your third formula. So then from a normal population with unknown variance, you draw a small sample. Case number 3. Case number 3 formula. Case number 3 formula is this one. So what about your case number 4 and case number 5? So now you are sampling from non-normal populations. According to the central limit theorem, they are approximately normally distributed. Right? Normal, they are approximately normally distributed. Case number 4. Now we are sampling from non-normal populations with known variance and unknown variance. Case number 4 with unknown non-normal population with unknown known variance. So once we draw a large samples, according to the central limit theorem, we should draw all large samples. Case number 4 and 5 we have to draw all large samples. Case number 4. Case number 4. Population is not normally distributed. Case number 4. Population is not normally distributed. Population variance is known for large samples. Sampling distribution of sample means are approximately normally distributed with population mean mu. This is sigma square over n. Approximately. So again, what is your formula? Same as your case 1 formula. Case 1 formula, but normal distribution is approximately x bar plus or minus z sigma over root. So then now this is approximately normal distribution even. So we have to use our Z table value. Approximate na Z value. Finally, what is your case number 5? What is your case number 5? Case number 5. Case number 5. Population is not normally distributed. Population variance is unknown for large samples. Once we draw a large sample, X bar is approximately normally distributed with population mean mu, variance is square over n. Approximately. Again, you have the same formula as case 2. Mu is equal x bar plus or minus z is over root. Now these are the 5 different formula relevant to each case. So then that is confidence interval about population mean mu. So you must write the correct formula by reading the question and understand well what is the case under this one. So we must write the correct formula. What about these formulas? A sampling distributions. What about this? Understood? How to construct the formulas according to each case? So there are 5 different situations of sampling distributions. Formula. Are you okay with that? Lamai,
Yes, President.
yes, right. Now we'll see there are two questions. මම මේ ගණන් දෙක හදනවා. මේකේ ගණන් දෙකක් තියෙනවා. ඊට පස්සේ ඒකේ exercise දෙකක් තියෙනවා. අපි ඊළඟ class එකට එනකොට මේ ගණන් exercise දෙක හදාගෙන එන්න. මම ගණන් දෙක examples දෙක හදන්නම් try එකක් දීලා බලන්න. So then most popular questions from this confidence interval regarding population mean එකෙන් තමයි වැඩියම අහන්නේ. ඒ හින්දා අපි මේ ගණන් දෙකක් විතර හදලා now we'll see how to do our exercises. Exercise දෙක homework එකක් විදිහට හදාගෙන එන්න. ඊළඟ next class will be on Wednesday. Wednesday ට ඉස්සෙල්ලා හදාගෙන එන්න අපි ඒතකොට උත්තර check කරමු. දැන්ට මම examples දෙක හදන්නම්. So to get an idea about that. ගැන අදහසක් ගන්න. Right. What is the example one? The average salary of 100 employees working in a firm has been computed as 25,000 rupees. The average salary of 100 workers. Okakari population එකකින් අපි employees ලා 100ක් ගත්තාම their average salary, that is sample mean, is given as 25,000 rupees. The variance of all these employees in the firm is 6,400. The population variance is given. So then the variance of all the employees in the firm, not the sample. Mean එක දීලා තියෙන්නේ sample එකේ, variance එක දීලා තියෙන්නේ all workers in the firm is 6,400. So then if the salaries of the firm are normally distributed, that this is from a normal population. Construct 95% confidence interval and comment on your answer. So before we get these answers and all, let me know this question is under case 1, 2, 3, 4 or 5. කොයි එකකටද මේ අහලා තියෙන්නේ? Sample mean එක දීලා තියෙනවා, population variance එක දීලා තියෙනවා. So then sample size එක. Now what do you think about that? Now this question is under which case? කොයි case එකද ඔය? This is under which case?
It's one.
Yes, case 1, exactly correct. Why we say that? The salaries of workers are normally distributed. That is the normal population, and sample mean and population variance is given. මේකේ දීලා තියෙන්නේ population variance එකයි sample mean එකයි. So this is under case 1. So what is your case 1? Population is normally distributed. Population variance is known for any size of sample. Make a large sample එකක් අරන් තියෙන්නේ. Even you have drawn a small sample, so then now this is a normal distribution. Now case 1 is valid for any size of sample. So by reading the question and understand the case, and then you have to use your correct formula, right? Example 1. 95% confidence interval under case 1. What is your formula? Mu is equal x bar plus or minus z sigma over root n. Sigma over root n. Now this is under case 1. This is under case 1. So what is your x bar? X bar is given as 25,000 rupees. So sigma is given as sigma square $6,400 square root. 80. Sample size is 100. So what is your Z value? Z value is 95%. That is 47.5% as 50. Your table value is 1.9. 1.96. Right. Now applying all figures and get that answer. Applying all figures and get that answer. Mu is equal 25,000 plus or minus 1.96 into sigma 80 over square root 100. Square root 100. (1.96) 80 over square root 100 කියන්නේ 80 over 10 8. What is your error term? Probable error plus or minus 1.96 into 8. Error term is 15.68. So then because of the nature of a population and by using the variance of a sampling distribution, point estimator plus or minus this range. හැම වෙලේම point estimator එකට ධන හෝ ඍණ කියලා මෙන්න මේ දෙපැත්ත තමයි අපේ population mean එක ඉන්නේ. So then subtract 15.68 25,000 වලින් ඒක අඩු කරන්න to 24,984 cents 32 in between mu 25,015 මේ පැත්තෙන් අඩු කරන්න එකතු කරන්න. Now this is your 95% confidence interval. So then salaries of workers, all workers of this firm is varies between 24,984 rupees up to 25,015 rupees under 95% confidence. See it 95ක් යටතේ. So then there may be 5% it has been rejected. So how you write your comment? Write your comment. Salaries of workers. මම මේ කියලා තියෙන එක බලන්න. Salaries of workers. Falls between 24,984 rupees and 15 rupees with 95% confidence. Make a lianda more. 95% confidence. You have to write this. So then there is a 5%. Can say the පහක් විතර තියෙනවා මේක වරදින්න පුළුවන්කම. So why we do this estimation by using a sample? Huh? By using a sample. අපි මේක sample එකකින් තමයි අරගෙන අපි මේ estimation එක කරන්නේ. ඒ ඉඳා so then validity of this statement is only 95%. 95ක් විතර තමයි මේක හරියන්න පුළුවන් හැකියාව. That is your normal comment. One theoretical comment is also there. මේ වෙලාවේ අපි theoretical comment එක ලියන්න ඕනේ. Now in practically, so your theoretical comment is once you take all possible samples from same size. අපි හිතමුකෝ අපේ population එක there are 1,000 workers in this company. So then we have to take 10 samples with size 100. 100 size 100 samples 10ක් අරගෙන. So then we calculate the confidence interval, 95% confidence interval of all these. So let's say like size of population is 2,000. 2,000 කියන්නේ ඔයතෝ ලේසියෙන් මට මේක කමෙන්ට් කරන්න පුළුවන්. So then in this company there are 2,000 workers. So then I can take size 100. There are 20 samples. Samples 20ක් ගන්න පුළුවන් size 100. අරගෙන so we calculate the confidence interval for each and every sample. So then there are different means with different samples. එතකොට මේ samples 20ෙම mean එක සමාන වෙන්නෙත් නැහැ වෙනස් වෙන්නෙත් නැහැ. ඒ හැම එකේම අපි confidence interval එක ගන්නවා 95% confidence interval එක අරගත්තාම so now we can make 20 confidence intervals. එතකොට sample 20ට අපි confidence intervals 20ක් ගත්තාම so then out of that 20 confidence intervals only 19 will be cover up the true population mean. එතකොට 95ක් කියලා කියන්නේ 20කින් 19ක්. එතකොට මේ samples 19ක් විතරයි අපේ population හරි population mean එක cover කරන්නේ. So only 95% of them will cover up our true population mean. That is our theory. That is the method. So we must draw all possible samples. But in practically, so are we going to take all possible samples with size 100? මේ 2000න් අපි ඔක්කොම samples 100 ගානි sample අරගෙන confidence intervals හදන්නේ නැහැ නේ. We draw only one sample. So that one sample may be so in a category of 19 samples with true population mean. හරියටම true population mean එක ආවරණය කරන 19 වෙන්නත් පුළුවන්. So then it may be the wrong one. ඒ කියන්නේ අනිත් එක වෙන්නත් පුළුවන්. ඒ කියන්නේ cover කරන්නේ නැති එක වෙන්නත් පුළුවන්. So that's why we write so in between these two range with 95% confidence. That is your theoretical comment. මේ අතර මේකනේ අපි කරේ අපි sampling distributions වලදී. So we take all possible samples. ඔක්කොම අරගෙන තමයි අපි මේ distribution එක හදන්නේ. But in practically now we drawn only one sample. මේ 20ම අපි ගන්නෙ නෑනේ එකයි අපි ගන්නෙ. මේ ගන්න එක sample එක may be with so then that may be with sample with cover up the true population mean. ඒ කියන්නේ අර true population mean එක cover කරන 19 වෙන්නත් පුළුවන්. ඒක නැති එක වෙන්නත් පුළුවන්. So that's why we write the word 95%. So then what is our practical comment? Our practical comment is salaries of workers falls between 24,984 and 25,015 with 95% confidence. එතෙන්ද හැම වෙලේම මෙන්න මේ කමෙන්ට් එක තමයි ලියන්නේ. මම හැබැයි theoretical comment එකක් දාලා තියෙනවා. So that is the mathematical theoretical comment. Right? So then you just write the comment with the given confidence level. ලියලා තියෙන confidence level එකත් එක්ක ලියන්න. Right. Then example 2. අපි දෙවෙනි එකත් බලමු. Example 2. Theoretical comment එකක් කියවලා බලන්න මොකද්ද කියලා. So I have given here a sample of 16 iron rods manufactured by a firm was drawn in random and maximum bearable weight of each was observed. A random sample of 16 iron rods. So then they calculate the maximum bearable weight. So then each. So it has been computed that the sample mean is 27.3 kilograms with sample standard deviation 1.2 kilograms. If the bearable mass of an iron rod falls normally, construct 95% confidence interval and comment on your answer. So then, what is this case? Now you drawn a small sample. So then, sample mean and sample standard deviation is given. Population is normally distributed. What is this case? What the case? 1, 2, 3, 4, or 5. You remember? Yes, case number 3. Why we say case 3? So now be carefully. If you have drawn a small sample, හොඳට බලන්න අනිත් ඒවා නම් එච්චර වැරද්දක් වෙන්නේ නැහැ. Small sample එකක් නම් ගන්නෙ. So then it may be case 1 also. Why? Case 1 is valid for any size of sample. හැබැයි මේකේ දීලා තියෙන්නේ small sample with sample mean and sample standard deviation. Small sample with sample mean and population standard deviation. ඒ කියන්නේ අපි මේ ගාණි ගත්තා නම් එහෙම. So once we draw a sample with 9, 30ට වඩා අඩු ගාණක් ගත්තත් so it follows a normal distribution. Small sample එක so then sample mean is given that is under case 3. එතකොට මේක දැන් case 3 එකක්. හොඳට බලන්න ඕනේ. So once we drawn a small samples. Small sample එකක් නම් අරන් තියෙන්නේ. හොඳට බලන්න දීලා තියෙන්නේ sample mean එකද population sample standard deviation එකද population standard deviation එකද කියලා. Standard deviation or variance whatever. මොකද්ද දීලා තියෙන්නේ කියලා බලලා identify the correct case. Now this is under case 3. This is under case 3. It follows a T distribution. It follows a T distribution. So then be careful about small samples. Small samples to number Example 2. Example 2, what is that? Mu is equal x bar plus or minus t is over mu. Now this is a T distribution. Small sample from a normal population with unknown variance. Variance එක දන්නේ තියෙන තමයි sample standard deviation. X bar is equal to 87.2. So S is equal 1.2. N is equal 16. N is equal 16. So what is the confidence interval? 95%. So then this is T distribution. 95%. So how we get the table value? 100% minus 95%. So it is 5%. 5% divided by 2. 0.025. What is your degree of freedom? Degree of freedom is 16 minus 1, that is 15. Degree of freedom is 15. Now follow up your normal table. Sorry, T distribution table. Degree of freedom 15. So what is your T table value under? 0.025. 50. What is your T value? T table value. What is your T value? Degree of freedom is 15, 0.025. What is your T table value?
Oh, yeah.
T distribution එක බලලා කියන්න කීයද කියලා? What's your T value? What's your T value?
2.13.
Yes, 2.13. 2.13. 2.13. That's correct. So then, learn how to use your T table. 2.13. Right, now we have to make your interval. So, mu is equal 27.2 plus or minus 2.13 into S 1.2 over square root 16. Calculate your error term. Plus or minus 2.13 into 1.2 over 4. What error term is 13 into 1.2 divided by square root 16 can happen. That is 0.639. 0.64 0.64. What is your error term? Point estimator plus or minus 0.64 kilograms. දශම 4ක්. ඒ කියන්නේ ග්‍රෑම් 640ක් වගේ එහාට මෙහාට වෙනවා. මේකේ maximum sample variable weight එක මේක sample mean එක. එතකොට 640 grams are so then on the each age. So then that is the 26.56 kilograms. Mu 27.2 plus 0.64. 27.84 kilograms. Now this is your 95% confidence interval. So then how we can see that? So maximum variable weights of iron rods. Normal comment.
Okay. Basically. So do you want me to get back to the directly or do you want me to?
Iron rods lies between 26.56 kilograms and 27.87 kilograms 8 feet with 95% confidence. Right. You have to select your correct distribution, write your correct formula. So now you have to write your comment. Now this is the method of finding the confidence intervals about population mean mean. ඒකට තව exercise දෙකක් තියෙනවා මෙතන. Read this very carefully and then identifying the case and construct the correct formula and get that answers. හිමින් සැරේ කියවලා බලලා උත්තර දෙක අරගන්න බලන්න කීයද එන්නේ කියලා. Exercise 1 and exercise 2. I'll discuss answers on the your Wednesday class. Wednesday class එකේදී මම ඒකේ උත්තර ටික ඔයගලන්ට discuss කරනවා. ඒතර බලන්න check your answers. You all have to work out these two questions. මේ දෙක හදාගෙන ඉන්න. එතකොට අපි බලමු ඒකේ උත්තර ටික. Right. What about the lesson today? You all understood? තේරුණාද පාඩම? What about the questions?
Yes, madam.
Yes, right. Right. Now we, yes, right. So put all your assignment marks to the group. Exam එකක් එමෙ ඉවරනා පොඩ ලකුණු එහෙම දාන්න අපි බලා ගන්න ආසයි ඒවා ඒකයි. ඒ හින්දා. Right? ඒ වගේ පොඩි වෙලාවක් යන්නේ ඔයගොල්ලන්ට message එකක් දාන්න group එකට message එක. හරි. එහෙමනම් so we'll see once again we'll meet on Wednesday. Wednesday අපි කරමු මේක ඉතුරු ටික. So complete your exercise and come. Right. Good night, all of you.
Good night, Miss.
Right. Right.
Good night, madam.
Right.
And then you can